Again, you've been given a pair of points like -1 form. It can be a turning point of a curve. So you have been asked to actually determine the nature of this turning point of a curve. So in other words, someone wants actually you to try and see whether this turning point of a curve is actually maximum or minimum. Now, my simplest way of doing this is this. I just come here and write x. I have to prepare a table, in other words. And in this case, I'm going to write here dy dx. I'll do that. Then I'll be able to actually determine the shape. So in other words, if I have to actually tell whether this is actually a maximum or a minimum turning point of a curve, I've only to actually use the x value and not the y value. So I'm going to pick -1, then write it in the middle here. Then I'll write a value that is less than -1 on this other side, then a value that is more than -1 on this other side. So I'm going to write here -2. -2 is actually smaller than -1. And I'll write here 0. 0 is greater than -1. So my dy dx that ended up giving me this in my previous video was this. I think you can be able to see this. Let me just look at what I've actually done. So it was this. It was actually somewhere here. So it was 3x squared minus 3 that ended up giving me -1, 4. I had already actually told you that this was the minimum turning point of the curve. We did that in our last video, and I actually ended up showing how I arrived at my final answer of actually suggesting that this is actually the minimum turning point of the curve. So how do I tell that this is actually the maximum? Because if this is the minimum, then obviously this one can become the maximum turning point of the curve. So let me see. Is it going to be the maximum or again the minimum, or a point of inflection? Increasing point of inflection or decreasing point of inflection? So I'll come here and write the dy dx as 3x squared minus 3. So I'll come and replace. Where there's x, I'll put -2 in the first case. So I'll say 3x squared minus 3. Then my value is -2 in the first case. So I'm going to say 3 into -2 squared minus 3. Okay, so -2 squared is 4. 4 times 3 is 12. So 12 minus 3. The answer is 9. Okay, so I'll come here and write 9. Great. I'll use -1 in my second case. So I'll say 3x squared. It is here. 3x squared minus 3. Value of x I want to use is actually -1. This one. So I'll say 3 into -1 squared minus 3. What do I have? 3. Of course, -1 squared is 1. 1 times 3 is 3. So 3 minus 3, the answer is 0. So I'm going to write here 0. And I will now use 0. 0 is now our last value of x that we will actually want to replace in the equation or in the dy dx. So I'm going to say 3x squared minus 3 as our dy dx or the gradient function. Then we have the value of x as 0 to replace in that equation to get the dy dx. This is actually what we are going to use. Here it is, so we are going to say 3 into 0 squared minus 3. This is 0. 0 squared is 0 times 3 is 0. So minus 3. Our answer is -3. So we shall write here -3. The shape, this is positive. You have to actually increase. 0, constant, negative, decrease. So this gives us something of this sort. So increasing, decreasing, of course, which is now constant. Then we have actually this other end. So this increases, this constant, this actually decreases. So I'm supposed to have something of this sort at the end of the day, where we have what you call the positive, we have the constant 0, then the negative. So this one becomes the maximum turning point. So -1, 4 is the maximum turning point of the curve. Just come up with the values that I've just given you here. You have the value of x here as -1. Put it in the middle. Write anything less than -1. I think anything more than -1. Get the dy dx. Right here the gradient function, replace the values of x in that gradient function, get the corresponding values of dy dx. Good. If it is positive, that's what you're supposed to do. 0, then negative. That becomes the maximum. Maximum. Positive, that is actually 9. That is 0, then there's negative 3. So you see, maximum. So negative 1, 4, as far as its nature is concerned, becomes the maximum turning point of the curve. Good.